Alright, so for this circuit, let's try to complete the chart. But by this time, we are dealing with parallel circuit. Okay, so before we start with the computation, let us fill in this chart first with the given value. So for resistor number 1, the given value is 3 ohms. Let's write it down. For R2 is 2 ohms. For R3, it's 1.5. Okay. RT, or total resistance, is not yet given because we need to solve it. Same with the total resistance, I1, I2, and I3. Similar thing with V1, V2, and V3. However, we already have the value for the total voltage, which is 10 volts. Right? So now, there are two ways to solve the equivalent resistance or the total resistance of a parallel circuit. The first one, let us call it as the product over sum. Product over sum. The second one, I do not know how they or what they call it, but for the sake of our discussion, let's call it the fraction method or fractional method. Just for the sake of our discussion. Now, let's use the first method, the product over sum method, okay, in finding the total resistance or the equivalent resistance. For parallel circuit, we need to work inward, meaning we have to resolve all the resistors first that are found outside, away from the voltage source. So in our case, we will resolve first R2 and R3. We will combine them to make it into a single resistor. So since R2 is parallel with R3, we can call it, let's say, R sub A. Okay, R sub A. So R sub A is equals to, again, I will be using the first method, which is product over sum, and we will be resolving these two. So that will be R sub A is equals to R2 multiplied by R3 all over by R2 plus R3. So we need to find the product of the numerator and find the sum of the denominator. So let's now plug in the value for R2 and R3 for the numerator and the value for R2 and R3 for the denominator. So for our R2, we have 2 ohms. And we multiply it with R3, which is 1.5 ohms. And then at the bottom, or at the denominator, so that will be 2 ohms plus 1.5 ohms. Right? So now, let me show you my calculator. For an easy reference, you can all you have to do is press this in the menu, the one that shows fraction here, and then plug in the given numbers. So for our numerator, we have 2 times 1.5. So let's plug it in. 2 multiplied by 1.5. And then let's go at the bottom. So that is 2 plus 1.5. So 2 plus 1.5. Then let's press equal. We want a decimal one here. So the answer is 0.857142. But let's round it off to 2 decimal place. Let's make it 0.86. 0.86 ohms. Now, if you will redraw this parallel circuit, you will have, this is your R1, and now we have a combined R2 and R3, which is now called RA. Now, R1 is parallel with RA, and since these are the two remaining resistors in this parallel circuit, we can now resolve for the total resistance or for the equivalent resistance. So I will be using again the product over sum method for determining the RT. So let's put it like this. RA is parallel with R1. So let's call it, since they are the two final resistors to be solved, let's call it as our R sub T, which is equals to RA multiplied by R1 all over by RA plus R1. And then, let's plug in the values for RA. RA is 0.86 ohms. We multiply it with R1. Our R1 is 3 ohms. All over by 0.86 ohms plus 3 ohms. So same procedure with the operation a while ago. So let's use our calculator again and press the fraction sign. So that will be 0.86 multiplied by 3, and then cursor down, 0.86, and then plus 3, press equal sign. So you want a decimal value for this equation. So we have 0.6683937824, but we only want 2 decimal places, so we will have 0.67. So 0.67 ohms. So we can say that this is our total RT. So that is 0.67 ohms. Now, there is an easy way to solve it, since they are only, what do you call this? They are parallel and there are only 3 components for this. So we can use the fractional. So what does it mean? Ibig sabihin, you have to apply the formula R over T, which is equals to 1 over by 1 over R sub 1 plus 1 over sub 2 plus 1 over sub 3. We only end up with R sub 3 because we have 3 resistors only. So how do we enter that? Well, you can use your calculator again, but for my calculator, I have to enter first all the numbers, the parentheses, like this. And then I'll press fraction sign over 1, and then at the denominator, I have to press again the fraction sign, so that will be 1 over by R1, which is 3, and then plus, have to press this again, go back, press the fraction sign, 1, and then over by R2, R2 is 2, and then plus, and then R3 is, so that you will see our R3 is 1.5. So that will be, let me plug in first the open and close parentheses and then the fraction. So that will be 1 divided by 1.5. Oops, sorry. So that is 1.5. So let's check the value for the different resistor again. So we have 1 over 3. This one, 1 over 3 for R1. And then 1 over 2. So this is the 2 or the resistance given here in the calculator. And then the third resistor has a value of 1.5. So in our calculator, we have 1 divided by 1.5. And then let me press equal. Then we want a decimal for that. That is 0.6. So let me write it down. For this method, we have 0.6. So almost similar with the product and sum. Why is it not equal to 7.8 or meaning 0.67? Because remember, we rounded off some of the values in the previous calculation. But anyway, this is still accepted. So there, if you want to use the product over sum, it's up to you. And if you think that the fractional or the method 2 is much easier, and then use it. Now, we already have the value for total resistance or the equivalent resistance. We can now solve for IT. Kasi we already have the value also for V sub T, which is 10 volts. This is the value for that, 10 volts. And current, in order to find it, we need to follow the Ohm's law or the Ohm's law formula. So I is equals to V over R. Okay, oh, by the way, this is important. You have to include the subscript. So this time we are solving for the total. So we need to put the subscript total so that we know what we are solving. We know what to look for. Alright, so since we are solving for IT, the voltage should be the total, the resistance should be the total or the equivalent. Now, substitute the value or plug in the value for V sub T, that's 10 volts, divided by the total resistance, which is 0.67 ohms. So, let's solve it using our calculator. 10 divided by, so that will be 10 divided by 0.67, that will give us 14.93. So 14.93 ampere. So by the way, here it is. I already wrote it down. 14.93. So let me write it down. For our I sub T, let me just erase that one. So that's 14.93. Now, for parallel circuit, by looking at this, we can see that the total current is divided into different components. So the total current splits into 3. We will call them as I1, the current that passes through R1 or resistor number 1. I2, the current that passes resistor number 2. And then I3, which is the current that passes resistor number 3. So that is the meaning of those arrows. And then once all these three current, okay, combined again, okay, the value is equal to IT. Alright, so meaning, in order to find the total current in the circuit, by using the individual current, we have to add them all together. So I1 plus I sub 2 plus I3. Now, for voltages, okay, whatever the total voltage is, that is also the same value for the individual voltage along this parallel circuit. So if the total voltage is 10 volts, V1, okay, in this component is also 10 volts. V2 is also 10 volts. V3 is also 10 volts. So if you will recall your Ohm's law when it comes to treating the voltages in a parallel circuit, we can say that the total voltage is equals to the individual voltages. So that is Vt equals to V sub 1, V sub 2 equals to V sub 3. So they are the same, 10 volts altogether. Now, we need to resolve for the individual current. Okay, so let's resolve first for I sub 1. So I sub 1 is equals to V sub 1 divided by R sub 1. Now, let's plug in the value for V sub 1. As I told you before, that the total voltage is equals to the individual voltage here or across the parallel circuit. So we have 10 volts all over by R1. Our value for R1 is 3 ohms. So that's 10 divided by 3. Let me use this again. So 10 divided by 3, that will give us 10 over 3 or 3.3. So 3.3. Now for I sub 2, we have to use voltage 2 and then resistance number 2 or resistance 2. So that is going to be 10 volts all over by R2, which is 2 ohms. So that will give us 5. Now for I3, so that will be V sub 3 over by R sub 3. That is going to be 10 volts divided by 1.5 ohms. So let's use our calculator again. So we have 10 divided by 1.5. And that is going to be 6.6. So let me write it down here. 6.6 ampere. Now, let us verify. By the way, this is the computed value for I3. Now, let us verify if this statement is true, meaning the sum of the individual current should be equal to IT. So let's add 3.3, 5, and then 6.6. Let's use our calculator. So that is, again, 3.3 plus 5 plus 6.6. And that will give us a sum of 14.9. Okay? 14.9 ang sum niya. So, 14.9 ampere, which is actually similar to the computed value using this equation. So now, we found out that it is close or similar with the computed value using this equation. We can now write down the remaining value in our chart. Okay, so let me just clear this check to show that we were able to complete the chart by resolving what is needed to be resolved. That's for parallel circuit. Okay, let's have another example here. So you can see a similar concept with parallel circuit. The current or the total current is being divided to the individual component, right? In this example, okay, the total current is divided into 3, no? I1, I2, and I3. Now, for the next example, you will also see that the total current, this one, I sub t, okay, is divided into 3. 1, 2, 3, the current 1 or the I sub 1 passes resistor 1, I sub 2 or current 2 passes resistor number 2, and I3 passes resistor number 3. Now, assume that whatever the subscript for resistor is the value of its resistor. So, for example, R1 here, let us accept that the value for R1 is 1 ohm. No? Just for simplicity. And then R2 is 2 ohms. And then R3, subscript niya is 3, then let's call it as 3 ohms. And of course, we cannot do that with current 1, current 2, and current 3. And we cannot do that with V1, V2, and V3, right? But, okay, later on, we can easily determine what V1, V2, and V3 because this is a parallel. If we know the total voltage, like this one, 5 volts, and since the circuit, the resistors are in parallel, we can say that Vt is the same as V1, V2, and V3. Just like in the previous example, this one, or this mathematical statement will tell us that whatever the value for the voltage source is just the same for this kind of component, okay, or for this kind of parallel circuit. So let me write it down. For V1, that's 5 volts. For V2, same 5 volts. For V3 is also 5 volts. Okay, now we need to resolve for the equivalent resistance. Now this time, let us use the second method, fraction method, or whatever they call it. I do not know, no? But for the sake of our discussion, let's just call it the fraction method. So that will be R sub t is equals to 1 all over by, since we only have 3 resistors, so 1 over by R sub 1 plus 1 all over by R sub 2 plus 1 all over by R sub 3. And then, okay, let's plug in the value. So that will be 1 all over by 1 divided by 1 ohm plus 1 divided by 2 ohms plus 1 divided by 3 ohms. So that will give us, let me use the calculator, right? So let me use this one first, and then the fraction sign. Okay, the fraction sign is important. Alright, the bottom, I have to input first the open close parenthesis and then the fraction sign. So that will be 1 over by 1, and then the plus sign, then the open close parenthesis again, and then the fraction sign, and then that's going to be 1 divided by 2, and then plus open close parenthesis again, and then the fraction sign, that will be 1 divided by 3. So let us check. 1 over 1, 1 over 2, 1 over 3. Let's go back. So that's 1 over 1, 1 over 2, and then 1 over 3. Let's press the equal sign. We want a decimal answer, decimal value for that. So that is 0.54. So 0.54 ohms. So that is our total resistance or the equivalent resistance. 0.54 ohms. Now, look at our chart. We already have the value for V sub t and RT. We can now determine our IT, right? And as well as the other values here, no? Such as I1, I2, and I3. Let's go first with IT. Okay, IT. So we have I sub t is equals to V sub t over by R sub t. So V sub t is 5 volts all over by 0.54 ohms, and that will give us, okay, let me use the calculator. So that is going to be 5 divided by 0.54. Press equal sign. That is 9.26. Okay, I just rounded off. 9.26 amp. Now let me write it down, and then let's now resolve I1. Okay, so I1 is equals to V sub 1 all over by R sub 1, and we have a 5 volts value for V1, and our R1 is 1, so we have here 5. Okay, so that's 1 ohm. 5 volts divided by 1 ohm, so that is 5 ampere. Right? Now for I2, that's going to be 5 volts all over by R2 is 2 ohms. So 5 divided by 2, so that will give us 2.5 ampere. Okay, number 3, or current 3, so that is going to be 5 volts divided by 3 ampere. So it has a decimal, going to be 5 divided by 3, that will give us 1.6. Okay, 1.6. Now, in a parallel, what did I tell you a while ago? The sum of the individual current in this given parallel circuit, I plus 1, I1 plus I2 plus I3 should be equal to I total. So let us add 5 ampere, 2.5, and 1.6. Alright, so we have 0.5, 0.6, so that's going to be 11. And then carry 1, 6, 7, 8, 9. So that is going to be 9.1 ampere. Almost near with our computed value here. Oh, let's check using calculator. So we have 5 plus 2.5 plus 1.6. That will give us 9.1. Okay? So 9.1 for the total. And then for I1, we have 5 amp. And then for I2, we have 2.5 amp. And then for I3, we have 1.61. Right? So we already completed the chart. And that's it. That's how you solve, or that's how you resolve for the missing value here in parallel circuit.